Hi everybody, welcome to another video in pre-calculus, section 9.6, polar equation of conics. So in this section we study conic section in polar form. Right, actually before that, if we take a look at the conic section defined based on the directrix and the focus. Then we said only parabola has directrix and focus, right? Yes, but now actually all of the conic section have directrix and focus too. But if a conic is the set of points in such that the ratio of the distance from the focus to a point P to the distance from D to P is equal to E, meaning that there's a lot of that, meaning that if we have a line, it's called the directrix, and then the point, the focus, directrix is D, focus is F. Let's say we have a part, let's say a parabola. If that is the case, we will take a point here, and that distance of that point to the focus and that distance to the directrix, the ratio is going to be constant, and that constant is called the eccentricity. Of course, for parabola, it is equal to 1 when they are equal, but in reality for ellipse and for a parabola, that ratio is going to be something else, but it's going to be a constant. Right. Now, and we say that for parabola, that is equal to 1 because they are equal. And if it is less than 1, it is an ellipse, greater than 1, hyperbola. Now think about this. Let's see. Okay. I have an ellipse, small ellipse. Right. And then have a directrix. Focus is somewhere, let's say in here. Actually, I should start with the parabola first. So this is an ellipse. Oh, sorry, parabola. Right. Now, if the ratio is less than 1, we have an ellipse. Less than 1 meaning that, let's just cross multiply. This is multiply that. The distance from the focus to the point is equal to A times the distance of the directrix to the point. Okay. Times. Now, if A is bigger than 1, that means this distance have to be smaller. By the way, if this is bigger than 1, meaning the top is bigger. So when for a parabola, the top is bigger, meaning the distance from the point to the focus is bigger. So when it's bigger than 1, the distance, when this is bigger than 1, the distance from the focus to the point is bigger than the distance from the point to the directrix. Let's say if this is the point, then the distance from this point to the focus is smaller, so it's not what we're talking about. If this is less than 1, then the top is smaller, so in this case the top to the focus is smaller than this, so in this case we will have an ellipse. And then if this is bigger than 1, the top is bigger, meaning that it is further away from the focus than the directrix, so we're going to have just a parabola like this. This is where A bigger than 1. When A is bigger than 1, then it is a parabola, meaning the top is bigger, meaning the distance to the focus is more than the distance to the directrix. And when it is equal, we have the parabola. When it is smaller, when it is closer to the focus, then we have an ellipse. And actually, the graph of this is occur in nature. A solar system, we know that we learned from grade school. The sun is at the center of the solar system, right? But actually, this is not quite true. The sun is at the focus of the solar system. So actually, the sun and the earth does not go around the sun in a circular path. It is elliptical orbit, and the sun is at one of the focus. The sun and the earth travel in an elliptical path, but actually extremely close to the circle. So that's why it doesn't make a big difference. So it's almost a circle. However, the Halley comet is extremely skinny like this. So the Halley comet travel in an elliptical path. The sun is at the focus. So it takes 75 years to travel one orbit. So the Halley comet travel in an elliptical path where the focus is at the sun. Same thing with the Earth, but the Earth is almost a circle, so we don't see much difference. But some other objects travel in the very skinny elliptical path. Right, now we go back to this. The sun is at the focus of the solar system. All the objects will travel around it in elliptical path. Actually, some objects travel around in the parabola path. If it is travel parabola path, we only see that once. So the comet that we see on the sky, sometimes we see the comet pass across the sky. If it is in the parabola path or in the hyperbola path, then we only see that once. It will never come back, because when it goes, it just gets further and further away from the Earth. The Halley comet takes 75 years to go back. So that's why it's roughly about 75 years we see the Halley comet. And that is extremely impressive. If it only go back about 75 years, how do we know it actually come back? I mean, the lifetime of a person is about that time too. So usually you only see the Halley comet once in your lifetime. And how do we know if an object is periodic if it's only seen it once, right? So That's an interesting fact. Right. Now, in this section though, what I really want to focus on is how do we go from this equation of the polar form of a conic section, and we'll turn that into an equation in rectangular form. So in polar form, the equation is given in this form, where E is the eccentricity, and then of course theta is an angle and we rotate, and then okay, the polar equation of the conics focus at the pole. So we just said that if we put the focus at the pole, just like the sun is the focus of the solar system, the directrix is perpendicular to the polar axis at the distance p on the left. So p is the distance from the pole, from the focus to the directrix. In that case, the equation is given by that. Like I said, the focus, what I want to do in this section is how do we go from an equation like that and turn into a rectangular form. Right. That should be, actually it could be complicated. How do we turn this into equation that have x and y in it? Well, first thing, let's take care of fraction. Cross multiply, right? So we have r times 4 minus cosine theta equal to 16. Now, this is a little problem here. If we square both sides, we have r squared equal to x squared plus y squared. That one's good. However, the cosine square, difficult to write that in terms of y and x. So in this case, just multiply it out. 4r minus r cosine theta equal to 16, right? And then add r cosine theta to the other side. By the way, what is r? R cosine. Well, that is x, right? In rectangular, that is x. So I will write 4r minus x equal to 16. Right? It's good there. Next, I'm going to move the x to the other side. And when we have r like that, we can square both sides. We don't want to square cosine or sine. So if we square both sides now, we have 16, 4 square 16, r square equal to x plus 16 square. And finally, r square is x squared plus y squared. Of course, we turn the equation into the equation that only have x and y in it. Right? Now, of course, we can multiply it out. 16x squared plus 16y squared. Multiply the right hand side, x squared plus 32x plus 256, that is 16 squared. And then move everything on one side, we have the equation. But, like I said, the point here is trying to turn that into a rectangular form, meaning only x and y in it. So, should be able to do that. And then finally, the summary of the polar equation of conics. Right. We don't have much exercise in this. It has a lot of application, yes, but usually when we do the problem, we just have to look at the form and then we determine the equation. But notice that what you need to know is the eccentricity bigger than 1 hyperbola, smaller than 1 ellipse, equal to 1 parabola. Right. Sorry, ellipse is bigger than 1 hyperbola. Okay. Yeah, I copy and paste and didn't pay attention. Less than 1 is an ellipse, and greater than 1 is hyperbola. Right. So we just need to know the relation between the eccentricity and the form of the conics. Right. What we need to know is in this section is how to turn this into rectangular form. Right. So first was cross multiply. Equal to 1. Multiply it out. And all cosine is x. So we have 2r minus 2x equal to 1. Move the 2x to the other side. And then we can square both sides. For r squared equal to 2x plus 1 squared. And finally, r squared is x squared plus y squared. Right. So, just need to know how to convert from the polar equation into the rectangular equation. And then the form of conic section in polar coordinates. Right. So that's what I want. That's all I want to cover in this section. Thank you for watching. See you in another video in pre-calculus.